Cool. So the abstract on the talk was about running the pizza shop demo, which I am absolutely going to do. But how many people, if you want to, I'm going to be looking off to the side because this is where I can see all of you. So how many people know about Apache Pinot? If you want to just give a little hands up emoji or other any sort of reaction. There's a yes and a no, so, and another no. Cool. So then probably going over a little bit of this stuff is appropriate before I jump into the demo, because if I just do nothing but the demo, you're going to be saying, why are we doing this? So anyway, this is me. I'm head of developer advocacy at StarTree. StarTree is the company that is sort of commercializing the Apache Pinot project. And I can give you a little bit of history on Pinot as well, if you'd like. So if anybody wants that, just speak up or there. So what is real-time analytics, which is really what Pinot does? It's basically providing insights for making better decisions. And the whole point of real time in here is that I'm able to make those decisions in real time. I'm taking in all of my data, I'm evaluating it in real time and making decisions in real time so that I can make better decisions right now, right? It's one thing to go and look back at your history from the last month and say, oh, well, we could have done that better, and okay, well, based on last month's numbers, this is what we're going to try to do this month. But it's an entirely different game when you can be looking at what's going on right now and saying, well, here's what's going on, and so we need to adjust in this way immediately. So basically, it's events. And almost anything can be an event, right? Sensor reading is an event. Somebody places an order, that's an event. Somebody pays for their order, that's an event, right? And from those events, we're looking to get insight about what's going on right now based on all the different events that are coming in. And from that, we can take action. And it turns out I've been saying I've been in the IoT space for 20 years now, and one of the things that I've said for so long I don't even want to talk about it, is that if you're collecting data and it's not actionable data, then you're kind of wasting your time, right? The whole point of collecting all of this data and being able to look at it is so that you can take action on it, make better decisions. And the more immediately actionable it is, the better off it's going to be. I see there are some questions in the chat. Let me just make sure that there's. Okay. So this is my professional graph, the value of data over time, right? It is highly valuable when it's happening right now. And the longer it sits there, the less valuable it gets. And you can define that unit of time to be, 5 minutes or 5 years. But the farther out you get in that timeline, the less valuable that data is, at least in terms of taking action on it, right? If you're trying to take action, you're looking for something up here in the immediate where it's highly valuable. Historical data is a whole other thing, and that's really not what we're talking about. So this is the real-time area. This is what's happening right now. This is where you're gathering your data and actually evaluating it as it's happening, right? These are the folks that are interested in that, analyst management, and it turns out users. You can do a lot to change how you interact with your users if you can use this real-time data in a way that can impact users, and we'll talk a little bit about that. So, machine-facing stuff is what we call observability, right? So I can see what's going on in my applications and in my overall infrastructure. Dashboards. We use dashboards to give us the illusion that we know what's going on, right? Whether they do or not is a whole other thing. Then there's the sort of the external facing, right, for things like fraud detection. And finally, there's things like order tracking. So when you order something and it shows up on Shopify, right, and you can track that all the way through the entire process, that's them using real-time analytics to present the data that they have to you in a useful format. And customers like that. LinkedIn, it turns out, uses real-time analytics all the time. So if you look at who's viewed your profile, if you look at pretty much any data that you're looking on LinkedIn, they're using real-time analytics. And in fact, they're using Apache Pinot. Apache Pinot was invented at LinkedIn in collaboration with some folks at Uber and some other places. But they have 700 million users. They're doing 10,000 queries per second. And they're looking for less than 100 milliseconds in response time. And this is one of the other things about real-time analytics, is that you're looking at sort of sub 250 millisecond response times. It's not going to satisfy your customers when it's 3-second response time. We all know what happens when we go to a website and it takes 30 seconds to load. We've already left. We have all of that patience built into us, right? Really useful on LinkedIn if you're in the talent side of things and you're looking at how your ads are doing, how your postings are doing, all those sorts of things. This is, again, real-time analytics of what's going on immediately, so you can see how your ads, how your articles, how your job placements are performing as they're actually performing, rather than waiting till the end of the month and getting a report on it, so that you can actually make changes now to get better reactions. And Uber Eats, and this is the pizza place, and we'll talk a little bit more about this because I'm going to run a demo. It's not an Uber Eats demo, but it is a pizza shop. And again, they have 500,000 users. They're only doing hundreds of queries per second, but again, they're looking for that sub 100 millisecond response time, so that restaurants know how many orders are coming in, how many drivers are available, all these sorts of things in real time, so that they can react in real time, right? And when you're ordering, you don't want to look at Uber Eats and say, well, yesterday the wait time was only 5 minutes, so I'm going to order today. Well, today the wait time may be an hour and a half. And so them being able to provide real-time insight into what the wait times are, what the delivery times are, is really useful to not just their business, but to you as a customer. And Stripe uses, as I think I mentioned, Shopify, but Stripe uses real-time analytics for detecting financial risks, detecting fraud, detecting anomalies, and also going back and auditing the past. So I'm kind of blowing through these slides because I want to get a little closer to the demo, and I don't want it to take forever. So properties of real-time analytic systems that are super important are speed of ingestion. I may be ingesting millions of data points, millions of events per second. And I may be ingesting them from Kafka and from a MySQL database and from a NoSQL database and from almost any other source. So I have to be able to ingest a lot of data very quickly. I have to be able to get queries done very quickly, typically under 250 milliseconds, in order to make it feel like it's actually responding. And I have to be able to scale it. So those are sort of the three most important things of what we need to do here. Get lots of data in, query it very quickly, and be able to scale it, because our data is going to start to scale. And if our business starts to scale, we don't want to have everything fall over on us, right? So if we're building such a thing, we're looking for real-time ingestion. We're typically going to have high dimensionality to our data. We're going to have a whole bunch of different kinds of data with a whole bunch of different dimensions to it. We need to be able to bring that all in. And the other one is which a lot of people don't think about, is the velocity of ingestion. How fast is this data coming at me? And it can be coming at me very, very quickly, right? And it's got to be highly available. And then again, on the query side, I need my data to be extremely fresh, as in the last few seconds, so that I can query what's really going on. I'm going to probably be doing thousands, if not tens of thousands of queries per second, and I want millisecond latency. Trying to do the tens of thousands of queries per second and millisecond latency at the same time is a very difficult problem. I worked on a lot of databases in my time, and it's a really hard problem to solve, to be able to do that and to do it well. So this is what Apache Pinot is, right? You can ingest from Kafka, from Spark, from Prometheus, from almost any data source. You can bring those events in, right? And we do smart indexing and aggregation, and we segment things and we turn them into different kinds of tables so that you can do those kinds of really hard queries in real time, right? And this is all for things like business intelligence. It's not enough to be able to run your batch reports for the last week. You really want to see what's going on immediately. And anomaly detection, right? Especially if you're in financial things, you want to be able to see when things are changing and not in a good way. When things crop up, you want to be able to see those things in real time rather than having to go back and look at yesterday's or last week's numbers and realize that somebody's been stealing from you for a week. If you can identify that in real time, then you can stop it in real time. Come on. My keyboard's not working. All right. Actually, I'm going to skip some of this just because I'm going to show you the demo. Yeah, let's jump into the demo. So I'm going to, I hope I don't horrify you by you actually having to see my desktop. I really apologize. First of all, let me just show you a little bit about what we're doing right now. StarTree runs a, we sell Apache Pinot as a SaaS product. And this is currently how many queries we've done in the last 7 days and how much data we currently have, which is a little over 21 terabytes of data currently. So we do a lot. We take in a lot of data and we do a lot with it. So let's. This is the pizza shop demo. And right now I'm going to make that a little bigger so y'all can see that a little better. But we have tried, what we tried to put together here is basically a simulation of a real pizza shop. And when you see some of the numbers, you're going to say, wait, what? That's crazy. But I will explain. This is all in a GitHub repo, and I'll post the link to that. And it's fairly easy to bring up. It's a little finicky at times. We are still working on making it less finicky. But I'm going to run a bunch of Docker Compose stuff to bring it all up. And it takes a minute to bring everything up. So we're going to bring up a MySQL database. We're going to bring up some Kafka instances, and we're going to bring up a Zookeeper instance and a bunch of other parts of the demo. And then we'll bring up, so you can see Kafka is starting and the Pinot controllers are starting and a Pinot broker is starting, and we're adding tables to it, and it looks like it succeeded. So let's actually find out if it did. First thing I'm going to do is just go see if the Pinot instance is up and running, and it seems to be up and running, and everything seems to be happy. So I can look at, let's say, the orders. Yep, there's orders, and this is just the raw data, right? So here's an order ID, and it shows what people have bought, and it's all JSON, and it's not really something that you want to look at in real time, right? This is not something that's going to really help you as a business owner to manage things. So let's go look at a dashboard that we have built. You can see that it's actually running in real time. We're refreshing at a 5-second rate. Now, I'm looking at the 1 minute of data, and this is one of the things that's a little weird. You can see that we've had the number of orders that have come in the last minute, how much revenue. This is not in American dollars, in case you're thinking that they're making $4 million a minute. No, this is actually based on we pulled a menu from a Domino's pizza shop in India. So these are all prices in Indian rupees. If I back the granularity out a little bit to 5 minutes, seeing what's going on in the last 5 minutes, I can actually start to see what the most popular items are, right? How many orders I've had for these, right? And I can see what the latest orders are, what time it came in. It was a placed order. And this is the kind of real-time insights that can help me run my business, right? Because I can see what's super popular. So I can make sure that my kitchen is putting those types of things sort of foremost on the table so that we can make those things more quickly, right? And I can see when things start to change. I can see when the most popular items start to change. I can go back and I can look at what was the most popular the last 10 minutes. Looks like it's pretty much the same thing, right? You'll notice that these are not things that you're going to find in a Domino's here in the States, but and so I can change the window that I'm looking at my data, right? And I can see sort of where my trends are going to go, where I've been, where I'm going, and again, I can see in real time what my most popular orders are and see them changing. One of the finicky things about our demo right now is that if I change this to 1 minute granularity, all of the most popular items and most popular categories disappear. And we're still trying to figure out what we built that was wrong about that to make that happen. But as soon as I go back to 5 minutes, and you can see that this is very fresh data, it's changing in real time. I'm able to do tons of queries against it in real time. I can do a lot of those same queries here. And in fact, these are the queries, but it's not really as it doesn't look as good. It's harder to keep track of. And I'm just selecting everything from orders. I'm getting the last 10, right? And this one, I have to keep refreshing because it doesn't have an auto refresh on it. There is a REST API, and that's actually how we built this, is by querying that REST API with, for the information that we wanted. So you can build front ends onto Pinot fairly easily because it's just REST API calls, right? We can look at our entire Pinot cluster. We can look at the configurations for the cluster, any state, who are the participants, right? And it's all laid out in JSON files. So it's pretty straightforward to bring stuff up and configure things because it's in JSON files and you can make those changes. And then again, there's the cluster manager. This is a cluster of basically one because I'm running it on my local laptop rather than in a data center. do we have any questions? I see how is Pinot different from Druid? I'm not really good at answering that question because I have not used Druid. So I do know that Pinot has much faster response times and can handle more data in real time. But other than that, I'm not quite sure how to answer that question. I should probably get a better answer for that. Does anyone have any other questions? You want to speak up with questions, or? I can go back and go through some more of the slides on Pinot itself if people are interested in that. We can go back over some of this architecture, and we're doing a little bit of this in the demo. We're pulling all of our data from Kafka right now, and then we've got these front ends that we've built onto it. But what's really going on is we have a cluster of Pinot servers and we have a Pinot controller. And the Pinot controller using Zookeeper is going to segment that data and distribute it across that cluster. And we'll distribute it in such a way that we can lose parts of that cluster and not lose access to that data, right? So I'll put different segments on different Pinot servers, and then I'll swap those around so that if I lose one of the Pinot servers, I don't lose access to all the data. It's always available on at least some of the nodes. And then I have a Pinot broker, which is where I submit my queries to. And the Pinot broker is going to submit those queries to the Pinot servers and actually get the response back. So the Pinot broker knows about all of the different Pinot servers and can feed all of that back in. Oh, and now we're at the demo done part. So basically, we're feeding events in, orders, order statuses. You can bring in events like if you wanted to instrument the kitchen so you knew how hot the ovens were and you knew how many people were standing in line at the shop and you knew how many people were working, you could also feed that data in. And we're just pointing that at Kafka and Pinot, and then poof, real-time analytics with a dashboard so that we can start making more educated decisions on what we're going to do with, in real time, how we're going to run our store, right? What do we need to order for tomorrow based on the orders that we're bringing in today? What do we need to stock? What do we need to restock? There are about 100 companies right now. We have about 2,400, 2,500 users in our user groups in Slack. We've got a bunch of GitHub stars. I think that's actually gone up quite a bit. And then you can see the NASCAR slide here of who actually is using Pinot in production, right? 1 million plus events per second with 200,000 peak queries per second. And again, millisecond latency, like 100 millisecond, less than 250 millisecond latency, because the latency is what's going to allow you to do customer-facing analytics so that your customers can interact with your service and not feel like they're being dragged down, right? And it's basically giving the power of actionable insights to our users so that they can make decisions based on what's going on. We'll make decisions based on what's going on that help us react to those, but they can also make decisions about, hey, I don't want to order that because there's a long wait on that one. But this other one, these other things that are most popular, it turns out we have low wait times on those, so I'm going to go ahead and order one of those, right? So it's really fresh data. It's a lot of data. It's fast querying, and at scale, because you're going to start to scale this. If you start to scale this to many restaurants, the amount of data that you're going to be ingesting starts to go up astronomically, and then the number of queries go up astronomically, but you still need to keep those query times in the 200, less than 250 millisecond range, right? So these are a couple of QR codes that you can use. The first one is me, and you can go and find me. Does Kafka work only? Does Pinot work only with Kafka today for data aggregation? No, it does not. You can actually feed data into it from SQL databases, from NoSQL databases, pretty much anything that you can query. You write a schema for it, and then you can start ingesting it into Pinot. The easiest way to do it is to point it all at different Kafka streams and have it all ingested that way. But you can ingest it without having Kafka in the middle. Absolutely. How many clusters are being used for the 7-day metrics I showed earlier? And have you seen any degradation with increase in clusters? I'm not entirely certain how many clusters we have running for that 7-day metric that I showed earlier. Those are on our cloud SaaS instance that we are running for paying customers. So I'm not privy to how many clusters we're running. We have not seen any degradation with increase in clusters. It seems to scale horizontally pretty well. Can I elaborate more on the dashboard I'm showing is built and show the queries and the schema that powers that dashboard? I can try. My Twitter handle has been down there in the bottom the whole time, David GS IoT. If you have any questions, you can always find me there. My DMs are always open. You can follow me and find me there. So what are the queries that we're running? What do they look like? Nope. I did not build this demo. I was just helping debug it. So we may have to go poke around in the order service. I'm trying to figure out where we've stored those. And I'm probably just going to bore everybody by going to try to hunt those down. So what I will do is I will track that down and get those answers to you as soon as I can. And the GitHub URL for this demo. Thank you for asking that. I will post that for you here. Let me find it. So
thanks,
that's
David.
Our repository and for this demo. We also have on our we have a free trial, so you can sign up for a free trial and you can fire up a Pinot cluster and start pointing data at it right away and see how it works. I believe it's a 30-day trial, up to 200 gigs of data from real-time and batch sources. So that's the other thing, is you can pull data in either in real time or as a batch. So you can batch some of the data in, and then you can stream the stuff that's real time and join those together and actually make queries against them both. Yes, I agree. The code that is used to build the dashboards. I'm getting ready to start a project of my own of building some dashboards using React, just because I'm trying to get less terrible at React. And so I'm going to start building some dashboards that way, and I'll be putting those on my GitHub as well. I believe I can. Send you, yes. That QR code, which also has a link to my GitHub. So you can see some of the terrible code that I write there, and you'll be able to see when I start this this project of putting some front ends on Pinot with React. Other questions? I know I'm done way early, but I really didn't want to give you, death by PowerPoint, because death by PowerPoint is exactly that, and nobody needs that. Do we have other questions?
If you're feeling shy, folks, you can just drop it into the Zoom chat as well.
And don't be shy. I don't mind questions.
Cool. Nice,
Okay.
nice comment from Rachel there.
Thank you. I figured I should go and do some of the basics, since almost nobody raised their hand as knowing about Apache Pinot. And so, starting at the beginning is often a good thing. If I just leapt into a demo and talking about all of this stuff, people would be most likely quite confused by it, right? And
Indeed.
rightfully so. I will say that this is not an easy product to get your head around and to get good at. There's a lot of stuff that goes into it. Our cloud trial is probably the best way to get something up and running quickly and sort of see the power of it, just because we have all sorts of stuff like a data manager that will help you import your data and set up your incoming streams of data and those sorts of things built into the cloud that are not built into Apache Pinot itself, right? Apache Pinot, the free open source version it's Pinot, but there's not a whole lot of the sugar around it to make it super easy to run and easy to manage. Most of that we have built on top of it as StarTree in our StarTree cloud. And since we give you a free demo, why not, right?
Yeah. Sounds good. And then what happens after the 30 days? Does your database just kind of hibernate or something, or?
It pretty much, I believe, goes away unless you convert to a paid account.
Got it. Okay, just curious.
Yeah.
Cool. Sounds good. And forgive me, I had to step away for a second a few minutes ago. I think we addressed all the questions that were in the chat, right, David?
I believe so.
Okay, cool. All right, I'll make sure this GitHub URL gets into the YouTube replay, folks. So Rachel, I'll shoot that over to you on email.
I already have it.
Oh, brilliant. Okay.
I will shoot you my slides, so you have all of those.
Very cool.
Perfect.
And David, I don't know if you covered this. Forgive me if you did cover this. I don't think so. But could you also? I'm a little new to this as well, and I was just curious. Can you give me a couple use cases other than the sort of ones you might have mentioned at the top, where you've seen people be successful with Pinot and or StarTree Cloud?
Most of the use cases where people are successful is things where they're wanting to provide a user experience, right, to their customers. It's one thing for us to build dashboards internally, right? But, and for internal stuff, we're willing to put up with a lot more than say, as a customer, you're willing to put up with, right? When you go to Amazon, you're not willing to put up with, garbage on the screen or, 3-second page loads or any of that stuff, right?
Right.
We want stuff now.
Yep.
We've been conditioned by the web to get stuff immediately. And so the things that are really successful with Pinot are the things that are trying to provide those sorts of real-time experiences to their customers, right? So, I'm assuming we almost all use LinkedIn, right? And
it's almost unavoidable.
Right. And LinkedIn, all of the insights that you see on LinkedIn are all coming through real-time queries to Apache Pinot, right? And so they're tuning their user experience to you by being able to provide you with really, really fresh data real time, so that basically you're seeing things as they happen on LinkedIn, right?
Yep. Yeah, I'm curious. Yeah, just because Cassandra talks a lot about. Oh, sorry, Robert. Please go ahead.
Yeah, please, Robert.
This is Robert. I used to work for DoorDash, and we used Pinot in production with StarTree's help. And at DoorDash, we used it primarily for merchant analytics, but also for ads. So high performance, low latent, like a lot of concurrent queries, and merchants that were logged in look at the performance of their restaurants and their items, and so a lot of those kind of analytic real-time use cases is another example.
Right.
Totally. Thank you, Robert. That's great.
Yes.
I've been. It's funny you mentioned DoorDash. I think they were Cassandra users as well at some point, or at least somebody at DoorDash was. I was reading a blog recently from about their real-time architecture. And I was just going to say that, a lot of the real-time cases that we go after are probably different from the ones that StarTree does, because Cassandra's more of an operational database. But, I think there's probably some similarity, things like location services, IoT sensor use cases, places where, as you say, David, that real-time is important, right? And maybe the milliseconds, do matter. Network security analytics, things like that, intrusion, those sorts of dashboards all have a very real-time kind of component to them, where data does not age well, right? In those scenarios.
Back in one of my first jobs that I had in tech was writing intrusion detection software for, shall we say, extremely secure networks for the federal government, where we stored lots and lots of highly classified data. And so, yes, intrusion detection, you want to see anomalies, and you want to see it. And this was back in the 90s, I was writing this, so it tells you how old I am. But you really want to be able to see this stuff in real time, because again, seeing that somebody breached yesterday is, for some of this stuff, it's game over by if it's a day old, it's game over, right? You need to know it like 3 seconds after it happens so that you can put a stop to it.
Yep. No doubt.
And we do have a product called Third Eye that is specifically for anomaly detection, right? And it's got some AI in there, so it's not just like, well, this value spikes, so that's an anomaly and will alert you to it. Well, not necessarily, right? That value might spike and everything's fine, right? It's if that value continues to spike that things get weird, right? Robert just said Third Eye is great. I use it at DoorDash. Yeah, it's actually really cool. I need to get a demo up of Third Eye as well.
Sure, yeah, that'd be cool.
Yeah.
If you have one, if you ever have one lying around, we'd be happy to publish it to the SF Java user group channel. That'd be pretty cool.
Yeah.
And then I guess if no one else has any questions, I guess maybe just my last one is I used to work at Elastic for a little while, and so I have some familiarity with the kind of like real time, but it's more, for them, it's a little more, they kind of have more of a search flavor to things, but there is definitely like an analytics and a dashboard aspects to things. So like how would if it's not too onerous of me to ask, I'm just curious for like a high level kind of compare and contrast between something that I think folks on the Zoom probably also know, being the Java product, they're probably familiar with Elasticsearch. So maybe a little teeny bit of compare and contrast if that's not putting you on the spot too much.
No, so I've worked at a couple of time series database companies, and those are really good for sort of operational stuff as well, right? For monitoring your cluster or your desktop environments across your company and these sorts of things, and finding anomalies in those, right? And there are different systems that are good at sort of one of those things or another one of those things, right? But it's when you want to start pulling all that together that things get really, really hairy, right? I want to pull together my analytics, my data from all of my systems monitoring with all of my analytics from my order system, and so that I can do things like I can scale my infrastructure based on incoming orders in real time, right? Which is harder to do if all you're doing is monitoring the infrastructure. But you have a separate system that's monitoring all of the incoming orders and the customer facing stuff. Because the orders may spike well in advance of the infrastructure starting to groan under the load, right?
Yep.
So if you can see the orders starting to spike and that is going to cause a load, and you're looking at both of those data streams, then you can start to make better decisions in real time because you have more information, right? And you haven't siloed your information between groups, or just, where you have to look at two different systems in order to see what's going on.
Very cool. All right, folks. Well, David, this is great. Thank you so much. I've, just partially just because my friend Kenny went to go work there, I was like, Pinot, what is that? So this was great. I selfishly wanted a little more of an introduction to it myself. So we really appreciate you coming tonight. And
keep an eye on dev.startree.ai. We are working towards making available very large data sets as sort of default data sets that you can just pull in, right? Things like the New York City taxi database, which is something like 1 billion rows of data, right?
I've done some demos using that database myself. That's funny.
I have too. I've done a lot of demos using that database, and you can really break a database with that, because it's like 1.5 billion rows of data now. And they're not, small rows, they're wide. And if you try to do queries against that and try to get those queries done in a short amount of time, you can really put a load on things. And so we're trying to bring a bunch of those data sets together, sort of ready to just do a sort of let's bring that data set up. And it will automatically ingest, and you can start querying it. And you can do things like bring up the taxi database in New York with the police complaints database, and you can cross-reference those in real time to see what's going, it's not all that, it may not be sort of real world, but you can at least see how these things interact and how you can do these complicated queries.
No doubt. Yeah. Yeah, it definitely helps to have a real data set when you're kicking around with it, rather than like, here, you can upload a 50 kilobyte CSV file. It's like, nah, yeah.
That's not real world, and if you're going to kick the tires on something like this, we want you to be able to do it with real data, so you can actually see what it's like and what kind of performance you can get out of it, rather than because anybody can get performance on a 50K CSV file, right?
Cool.
Yeah.
All right, folks. Any last questions? I mean, we have a little more time if we need it, so don't be shy. And we don't have next month's meetup scheduled just yet, but in the works. So normally this is the moment where I like to announce next month's meetup. But we're negotiating a little bit with some presenters that got COVID. So stay tuned. You'll get a notice from your friendly neighborhood organizers as always. Yeah, so cool. I think in the meantime, go check out StarTree Cloud and some of the sample data sets and play around.
If you have any questions, just reach out to me. I'm always around, either email or Twitter or however. All my contact information was in that QR code I put out. So
brilliant. Okay, cool. All right. And that's in the Zoom chat, folks. There's a little PNG, the QR code right there. So if you need it. And David, thanks again for coming. Looking forward to getting another update from you, perhaps later in the year. Yeah. So keep in touch. If you all have a big release coming up, I'd love to hear about it and have you back on the user group.
Love to do that. Love to.
Cool.
Thank you. Appreciate your
David,
time.
had a wonderful evening. Stay safe and Happy New Year, everyone. Thanks for coming tonight. Appreciate it. And go to YouTube, hit subscribe, and you'll get the notification on the replay. I'll just drop the URL one last time here in the Zoom. That's right, Zoom. Zoom still doesn't support copy and paste. I don't know if anyone has noticed that, other than me. Like, you can't copy and paste stuff.
Oh, I do all the time.
I noticed that tonight.
I don't know what it is, but anyway, I'll just go get it out of my browser. All is well.
I'm pretty sure I copy pasted the GitHub URL.
Who knows? Might just be my machine or something. Who knows? That I'm cursed, but I feel like it's so consistent that there's something to it. Maybe it's just Mac or I don't know. But anyhow, all right, folks. Take care. Happy New Year. Yeah. Okay. You're on Mac too. Is it Ode? Hopefully I'm saying your name right. Odie. Yeah, I don't know. It just seems like one of those things that should work in Zoom, doesn't it? All right. Yeah. Have a great night, everyone. Thanks for coming, and I look forward to see you next month. You'll get a notification soon about next month's meetup. Cheers.
Thank you.